welcome to today's class. So we're going to pick up from where we stopped in the last class. Last class we started metrics, we did the introduction of metrics, we did addition and subtraction, we did equal matrices, we did multiplication of matrices. So now we're going to go into determinant of a matrix, cofactors and adjoints. Now the determinant of a matrix is similar to cross product of a vector. Yes. So that's overall determinant. It's very simple. So now let me show you what you have to do to get determinant of a matrix. Now let's write the topic right here. Now, if you are given a matrix A, let's take this matrix. You have to find the determinant of this matrix. The only thing you have to do is you have to pick this first element of the matrix, cover this column, cover this row, and we are dealing with just this matrix now. We pick this one, cover this row, cover this column, and we are dealing with these ones now. Cover this one, cover this one, we are dealing with this now. So it is very simple to find the determinant of the matrix. So now let's go. Now these three numbers here, because we are working with these three numbers here, they carry a sign. It starts from positive, negative, and positive. Now I'm going to show you where you are going to apply the signs I told you about. So now we are going to pick 6 now. This element 6 into. We are going to close this part, this row now, and close this column. You are left with this matrix now, this square matrix now. So what we are going to do is we are going to multiply this one and minus it with this one. That's very simple. So we go with 2.0 minus 2.1 or 1.2. See the same thing. Close our bracket. Now remember I told you this place is positive, negative, and positive. Now this negatives comes in. We have 2 now. This 2. We open our bracket. We cover this row and cover this column. When we cover this row and cover this column, we are left with 2, 1, 3, 0. So now we multiply 2 by 0. That is 2.0 and minus it with 3.1. We are done for that. And we go into 3. Remember 3 was positive here, so that's why we have positive. And I'm sure you know there's a positive here, but we don't use to write it in mathematics. So now we cover this row and cover this column. We are left with 2, 2, 3, 2. Now we multiply 2 by 2. 2 by 2 minus 3 by 2. We are done. Now you sum up everything and know your determinant. So here goes, here is 0, so this is 0 minus 2. So this is 6 minus 2 is minus 12. Moved here. Here is 0, 2. This is minus 3. Minus 3 minus 2 is plus 6. Come here now. Plus 3. This is 4 and this is 6. 4 minus 6 is minus 2. Minus 2 times 3 is minus 6. So now, this 6 cancel out this 6. We are left with minus 12. So our determinant of A is minus 12. That's all for determinant. Now let's go into cofactors. Now a determinant of this matrix now is denoted by this. That's how we denote determinant. Just like in transpose, we denote transpose with something like this. So this is how we denote the determinant. We are going into cofactors now. Cofactors is just like dealing with equal matrices, except you have to equate both matrices like this. Now, I am given a matrix A. Let's take 3, 2, 1, 4, 2, 6, 2, 1, 1. We are asked to find the cofactors of the elements of this matrix. The cofactors will wipe out determinant. Also given another, we are going to equate this 3 by 3 matrix with another 3 by 3 matrix so we can find the cofactors. Let's take another matrix. A, B, C, D, E, F, G, H, I. Now, we're going to equate these two matrices and find the cofactors of each element of this matrix. Now, remember in finding determinants, we were working with these three numbers here, these three elements, sorry. Now we are going to work with everything. So remember in determinants, we had positive, negative, positive. Since we are working with all the elements in here, these elements also carry their own sign. So here is negative, positive, negative, they interchange. So it's positive, negative, positive. That's for everything. So now, if we want to find the cofactor for A, write out A, say A equals. Remember when we were finding determinant, we covered this place and here. Now we were left with this. But since we are equating the two matrices, we are going to work with 2, 6, and 1, 1. So now, what we are going to do, since here is plus, we don't write anything. So open our bracket, 2.1 plus 1.6. A equals 2.1 is 2 plus 6, that is 8. So the cofactor of A is 8. Now let's do for B. For B now, we do the same thing we did when we were solving for determinant. You cover this first column and this second row. Now we are left with D, F, G, I. But since we are equating, we are going to be working the both matrices. Now, so we are left with 4, 6, 2, 1. We are going to multiply 4 by 1. Remember, it's negative, so write our negative out. 4.1. So we made a mistake here. It's always negative here. Negative, negative. So 2.1 minus 6, that's minus 4. That's the cofactor for A. Now, working with B, we did 4.1 and 2.6. So it's 2.6 here. 4.1 is 4 minus 12. 4 minus 12. So here is minus 8. Minus minus turns to plus. So here is 8. Go for C. C is positive, so we don't write anything there. Now we close here and close here. Now we are left with these 4 elements now. That is 4, 2, 2, 1. So we are going to do 4.1 minus 2.2. 4.1 is 4, 2.2 is still 4, so C is equals to 0. Now let's open another matrix and write in these elements we had here. So this is 4, this is 8, and this is 0. So we can wipe out these ones. Now we do the same thing for D. But now remember, D carries a negative. D carries a negative, so we write its negative here, then open the bracket. Now we cover here and cover here. And we are left with BCHI, that is 2, 1, 1, 1. We are going to multiply 2 to 1, that's 2.1 minus 1.1. 2.1 is 2, this is 2 minus 1 is 1, minus 1. Go for E. E is positive, so we cover here and cover here. We are left with ACGI, that is 3, 1, 2, 1. So it's 3.1 minus 2.1. It's 3 minus 2, so we have 1. Go for F. Cover here and cover here. So we are left with ABGH. That's 3, 2, 2, 1. Yeah, that's right. 3, 2, 2, 1. We are going to say 3.1. F is minus, remember. So write out minus. 3, 1, 2, 2 minus 2.2. 3.1 is 3. That's 3 minus 4. That's minus 4. 3 minus 4. 3 minus 4 is minus 1. Minus minus is plus. So you have 1 there. So this minus 1, 1, 1. Minus 1, 1. So now let's go for the last line. Do for G. Now we cover here and cover here. So we are left with BC, EF. That's 2, 1, 2, 6. So 2.6 minus 2.1. 2.6 is 12. 12 minus 2 is 10. Go for H. Remember H is minus, so you write out the minus. Cover here and cover here. We are left with AC, DF. That's 3, 1, 4, 6. So we're going to say 3.6 minus 4.1. This is, remember we are working with H, so we cover here and cover here. We are left with ACDF. That is 3, 1, 4, 6. So now we are having 3.6 and 4.1, not 3. This is 18 minus 4. That's giving us 14. Minus 14, remember. Minus 14. Now I as the last. We close here and close here. Let's say AB, DE, that's 3, 2, 4, 2. 3.2 minus 4.2. 3.6, 4.2 is 8, so that's minus 2. 10, 14. 10 minus 14 minus 2. So this is the cofactors of the elements here. That's everything for cofactors. Now I'm going to go into adjoint. Now, in adjoint, I'm going to write out the steps because it's just a step from here. When you have asked to find an adjoint, you are given a matrix, you are asked to find an adjoint. The first thing you are going to do, you are going to calculate the cofactors. You are going to have the cofactors first. Then the next thing we are going to do, when we have the cofactors, now these cofactors, we are going to transpose. Then when we are done finding the cofactors, we transpose the cofactors. So now we have C transpose. We transpose the cofactor. Let's claim these cofactors because they are now in adjoint. We are going to transpose the cofactors. When we transpose the cofactors, we have the adjoint. So now, if we are given this matrix now, to find the adjoint of this matrix, number one, we have already calculated cofactors, and this is the answer we had. Now we are going to transpose these cofactors. Like in the previous lesson, I taught you guys how to transpose a matrix. The only thing you have to do is change these rows and make it the first column. Like that for the second row and the third row. So now, this first row now is minus 4 minus 1, 10. To become minus 4. Remember it was a row before. Now I'm going to change it to a column. So it's minus 4. Instead of the minus 1 here, you're going to write minus 1 here. And then 10 here. That's for the first row. Then the second row now changes now. So it's 8 1, 14. The third row 2 changes, so 0, 1, 2. Now this is the resulting matrix. So this is the adjoint of A. Adjoint of A is this. The first thing you do is find the cofactors, then you transpose the cofactors. That's everything for adjoint. Now I'm going to get into inverse. So now, like I said, we are going to go into inverse of a matrix. We are going to still use this matrix now, so we can continue. The inverse is just a step away from the adjoint. When you are done finding the transpose of C, you have the adjoint A. Now we are going to have the inverse of this matrix now. We are going to find the determinant. This is where the determinant comes in. We are going to find the determinant, then we are going to use the answer we got from the determinant and use it to divide every element in this adjoint. That's the inverse of the matrix. So now let's find the determinant. Remember, the determinant, we are working with just these first 3 elements. So we are going to write out 3. We close here, we close here. We are working with 2, 6, 1, 1. So it's 2.1 minus 6.1 or 1.6. Still the same thing. Minus 2. I hope you know why we wrote minus here. So close here and close here. When we close here and close here, we're going to 4, 6, 2, 1. So it's 4.1 minus 6.2 plus the last element here now. We close here and close here. We are left with 4, 2, 2, 1. So we are going to do 4.1 minus 2.2. And we're going to sum up everything I have our determinant. So here is 2 minus 6. That's minus 4. Minus 4 times 3. That's minus 12. Minus. This is 4. And this is 12. That's minus 8. Minus 2. Minus 8 minus 2 is minus 10. Okay, sorry, we are multiplying because that's a bracket here. So we are multiplying. This is 4 and this is 12. So this is minus 8 multiplying minus 2. Minus is plus. So 8 times 2 is 16. We are done with this 2 now. And we go here. 4.1 is 4. Minus 2.2 is still 4. So here is 0. 0 times still 0. So we leave it at 0 or we don't write anything. So minus 12, sorry, plus 16. Now we get our answer. Our answer is 4. Remember what I said in the inverse, you find the determinant. This is determinant now. Determinant A is equals to 4. We are going to divide the adjoint with 4 to get the inverse. We can choose to divide everything here by 4, or we can just write 1 over 4 outside here and have our inverse. Write inverse like this. That's our inverse. So if you are given a matrix like this, the first thing, if you are asked to find the inverse of this matrix, the first thing you are going to do is find determinant. Here is your determinant. When you are done with finding your determinant, you keep your answer somewhere. You find your cofactors like we did, then you transpose your cofactors, then you divide your transpose now with your determinant. That is 1 over 4. And that's everything for inverse of a matrix. Thank you.